Welcome to the electronics course at the college level. This is the basic electronics course about quarter course. The course is for students in electrical engineering, electronics, computer science, and robotics, mechanical engineering for making robotics, and anybody who use electronics. This course is a basic one. We start with a very basic, very basic at the college level to all the way to chip design and microprocessors control the entire electronics board design. It's about 30 videos. This is the first one in the series. Okay, so let's begin. In order to understand the electronics, we start with the very basic. What is the basic is we understand the linear component. What the linear component? Linear component is the very basic one is resistor, and when you have voltage applied, the current and the voltage relationship, this become linear. So current and the voltage has a linear relationship. Okay, so this is the simplest one. But even the linear resistor, there are various characteristics like temperature. It has a temperature. Resistance is basically the function of temperature, and also depend on the resistor range. Its manufacturing method change quite a lot. For example, in order to sense the current, we use very small resistor like 0.01 ohm. And making such a small resistance is very difficult, because if you have a 10% variance in the resistor value, the measurement change by 10%. So how we use this? We use this to sense the current to the load, and there's no voltage drop here. It doesn't affect the system by inserting this resistor, but you can still measure it. When resistor value is very big, like 100 meg, so this is almost like no current flowing, this insulation. But when it's come to 1000 volt, megavolt, then resistance is a totally different animal. It's no longer linear. Okay, but this Ohm's law is a very basic of electronics. How about other component? Capacitor. Okay, when you apply DC voltage, what happened to the capacitor? Okay, so this is DC voltage and small resistor here and capacitor here. Okay, then the voltage across the capacitor is going to be like that, right? After you connect it. So it's current to start flowing to capacitor, eventually saturate, and it doesn't go anymore. And this is going to be E. So it is almost same as disconnected here. Okay, so DC voltage capacitor is not linear. So what's happened to the voltage current characteristic around the capacitor for this kind of voltage, the DC or non-AC, any other voltage, is called transient characteristic. And after transient characteristic, this is a transient area. After transient characteristic, it's become the same as not connected. It's disconnected. Okay. Now, why capacitor become linear? When you have AC sine wave voltage source, then what happened? Okay, so you have a current here and the voltage across the capacitor. The relationship is going to be I dt 1 over C. Okay, so this is a charge stored. So basically charge stored is the time function C. So Q is the time function of the charge stored in capacitor. Divided by capacitor is going to give the voltage, right? So so if I is sine wave function, we express sine wave as a sine omega t plus phase, and this integral is just 90-degree shift in phase. The using complex number, the vector shift 90-degree. So basically we can say E we can express by complex number omega c, j omega c I, right? And I, is a current flowing, and if I is flowing R2, then total this AC we express AC is R plus 1 j omega c I. Okay, so this part is called impedance. If R is very small, this small r is negligible, then this become impedance. We call impedance instead of resistor because we use complex number. Using impedance, voltage equals impedance times current. Here you go. So this is Ohm's law. So this is extended Ohm's law for AC system. So AC system, capacitor become linear. And I explain to you later why being linear is so important. Some of you learn in another class probably Kirchhoff's theorem. Kirchhoff's theorem or method is to analyze any circuit diagram. And Kirchhoff, as long as element is linear, you can put all of them together as you like, and you can analyze and you can calculate the voltage and the current at any branch. Okay, it's become just linear simultaneous equation and solve it, and we can get any value. So the circuit analysis is Kirchhoff theory is the essential, and the Kirchhoff theorem is extended to nonlinear element later, like transistors and diode. Next video we talk about characteristic of diode and transistors, bipolar transistor and MOS transistor. So I explain how to extend the linear system into the nonlinear system. So basically, any circuit diagram with transistors and linear component can be solved. And in order to solve that, you can do hand calculation. There is a good software already created, the SPICE. The SPICE software can analyze all the circuit, but it's come from this Kirchhoff theorem, which require element to be linear, and for nonlinear use iteration method to get the approximate value of the voltage and the current. Okay, so you look at capacitor is if the power source is sine wave, then we can say this is the linear component. If DC, it's nonlinear, and this going to require integral for transient analysis. But integral becomes simply 1 over j omega c I, and this is capacitance impedance, and the voltage across the capacitance is impedance times the current. So it's AC, it change plus minus all the time, so current go back and forth. The capacitor is charged one way and charged the other way in the next time, and charge back to the original way, so on and so. How about inductor? Inductor is a coil, right? And inductance is defined by L, and voltage across C. If you put DC current, what's happened? Small resistor, inductor, right? So what's happened is the voltage across inductor initially it's certain entire voltage, and it's come down to 0. Okay, and 0 means after a while it's become as a short circuit. Okay, so again, inductance in the physics we learned the voltage across inductance is going to be di dt L in front, right? And di dt, if again AC power source so I is now sine wave, right? And if you take a derivative, E becomes j omega L I, and this is impedance. So this is the impedance of inductance times current become voltage across. Again, it's a linear. Okay, so inductance, you need a transient analysis for any voltage source other than clean sine wave. But when voltage source, the circuit system is using sine wave, then it's going to be the linear component, and the impedance for the inductance is J omega L. And J simply show that there is a phase shift in the sine wave across inductance. The same thing, phase shift, but it's 1 over J. It's the other way around for the capacitance. Okay, so remember this. This is the very important things. The AC system, capacitor and inductance becomes linear element, just like resistor, simple linear element. Okay, so why so important? We talk about that next. Okay, let's summarize here. We have a resistor R, and the relationship between current and the voltage is E equal Ri regardless of the frequency. And now we have another linear, this is C, and the relationship between I and voltage is IDT. And when I equals A sine omega t, then E is minus C omega A cos omega t. So this is same as AC change it to plus omega t minus pi over 2. So phase shift. This is become the phase shift. Inductance L the same way. E is inductance L di dt, and if I equals A sine omega t, then omega inductance L A cosine omega t. This cosine omega t is basically okay. So phase shift is phase shift the opposite way. So this is same as phase shift for the AC signal, and it's all become this will be expressed this way. Is when I is sine wave, okay, then E is going to be this negative cosine. So start from here like that. So when current flow one direction, this amount of current accumulated, so the voltage increased from negative. Previously it dropped to negative and go to the maximum voltage. Then from here the current flow opposite, and this much charge goes out from a capacitor, so the voltage drop to negative again. Here time, if current is flowing this way, sine wave, okay, then it's from here, current flowing, the voltage across the inductance is highest for this rate of current flowing, and it's become current stop increasing, so it's become zero here, the voltage. Then it's a negative direction, voltage increase to maximum, and here becomes zero again. Okay, so this is a current, the voltage E, this side E. So it's a phase shift. When you have a phase shift, not exactly pi over 2 or negative pi over 2, somewhere between. Okay, so we use complex number I and say this is I, current I, and inductance is shown here, pi over 2 ahead in the phase. So this is going to be the E inductance. On the other hand, capacitance is going to be other way around, E capacitance. So there is a different phase. When you mix those linear component, for example, like this, then this phase shift is going to be not exactly 90 degrees, somewhere around. So it's going to be R, and it's going to be J, C, omega, I, Ri, and J omega L, I. So it's going to be voltage is R plus J omega C plus J omega L I. So impedance is going to be a complex number, and that means when I is a sine wave, then E is also sine wave, but phase shift by the amount of theta has a real component and imaginary component in this impedance. So impedance shows impedance has a two component, real number and the imaginary number part, and both of them the tangent is going to be the phase shift of the sine wave. Okay, so basically this is the basic of the electrical engineering. You learn this, but electronics, this is the must. You have to understand this part. Okay, now we go to hand-on electronics. So we're going to show you what kind of tool we use for hand-on electronics in this course. This is the breadboard. It's a small breadboard. Breadboard has many holes, and certain lines are short circuit. For example, I have a power supply as a ground, 5 volt and 12 volt behind this, and this line is all short circuit to be ground, and this line is 5 volt, and I pull out 5 volt by red wire here, and ground to this. So this all ground and this 5 volt. Okay, the same way here. I have a unit here, it's a power generator. So it's very cheap. You can buy like temu.com. Right now it shows 1000 hertz, 50% duty cycle. It's generating perfect pulse, square pulse, duty cycle 50%. And I have a voltmeter, kind of stylish voltmeters. It can measure also the capacitor. And also I have a little oscilloscope. Oscilloscope used to be bulky, big desktop, cost 3,000 to 10,000. This 2-channel oscilloscope is only like $60, and it's good enough to see the waveform and measure the timing. Basically use this kind of wire to connect from this point to this point, like that. Okay, so this is a tool we're going to use from now on for electronics, hand-on electronics project. Okay, so today is just information about what kind of tool you should prepare. They sell those breadboard electronics tool kit. Is you buy as a kit, it's pretty cheap. The color code for the resistor is the first line and second line is a 2-digit number, and the number of the code, the 0 is black, and brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, and gray 8, white is 9. Okay, now there is one more line that shows the quality of the resistor, and if it's gold, it's a the variability is 5%. If it's silver, it's 10%. And most likely they select out during manufacturing, take the gold out, sell a little bit higher price, and the remaining they mark silver. So remember this color code. As, for example, if first one is brown and this green is 1,5, and the red is 10 to the second, so it's going to be 1500. So this resistor value is 1.5K, right? And this capacitor, I show one of them. It's one lead is longer. It has a polarity, and you cannot use the wrong polarity because breakdown voltage is different. It's called electrolytic capacitor. In order to increase the capacitor capacitance, they use very thin insulation layers. So usually breakdown voltage is low. Most of capacitor has over 5 volts, so no problem using in the circuit. And there are other kind of capacitors, as paper type, polystyrene, bipolar, and those are all no polarity. You can use either way. This has a polarity. Okay, polarity is indicated like one lead is longer, then it has a polarity. If same length lead, is pretty much no polarity. And inductance, there's a coil. The inductance is depend on how many turn and the length of the coil is going to determine, and the material inside is like in the physics you learn the magnetic material inside to hold more magnetic flux. So in order to increase the inductance, they put some magnetic material inside. Okay, so these are the basic linear component. The next video we talk about diode, various diode, and Zener diode, and transistor, bipolar, and MOS transistors. Okay, thank you for listening.